This is example 9.1 from Discovering Design with Chemistry. The problem says a chemist has a solution of sodium carbonate and another solution of aluminum nitrate. When he mixes them, a precipitate forms. If aluminum carbonate is insoluble in water, what is the chemical equation for the reaction that happened? All right, so it's very likely you're coming back after a holiday break for this chapter, and it's also very likely that last chapter was a lot to take in to begin with. So as we start doing problems from here on out, I'm going to start kind of walking through not just why we're doing it, but also the process to figure out what do I do with this. So let's start by looking at what we have. We have a solution of sodium carbonate. So what are your what is your symbol for that? So sodium means you've got an Na in there. And carbonate is one of the ones that you're supposed to have memorized. So that's CO3. Now this one has a -2. And sodium is over here. So that one has, I should have written that the other way. I should have written it 2 minus. And then this has a plus. So when you combine those two, and you get this way, and this way, you have Na2CO3. And then the other solution is aluminum nitrate. So we have aluminum. And then nitrate is another one of those polyatomic ions that you need to memorize. That's NO3. O3. Now aluminum is right here, so it's in column 3A, so it has a 3+ charge. And nitrate has a plus charge, so when we switch those, 1 here, 3 here, we're going to have aluminum. And then nitrate, we have to put parentheses around it before we add that 3 down there. So now we have our two things, and we're mixing them. So plus. All right, so a precipitate forms. If aluminum carbonate, so here's a new one, we haven't done that one yet, is insoluble in water, what is the chemical equation for the reaction that happened? Aluminum carbonate must be our precipitate coming out. We can also go back and include in here that this is aqueous, and that this is because they tell us it's in a solution. All right, so let's get our aluminum carbonate. Aluminum we already have from before, that's 3+, and carbonate we also have from before, that's our CO3 with a 2 minus. Oh, why do I always write it backwards? 2 minus. All right, so our 2 and our 3 are going to swap, and so we'll end up with Al2CO3 with a 3 on there. And because that's a precipitate forms, this is the one that's going to come out solid. And then we kind of have to see, well, what else is left? So I guess I'll keep using purple. So we've used our aluminum, we've used our carbonate, so the two things that are left are the sodium and the nitrate. So let's add those in. So sodium and the nitrate. Now sodium was, and if we can't see the whole periodic table, but you can kind of see right here, sodium was our one that had just a plus, this was a plus, and then nitrate was also a plus. In other words, these two don't need any symbols with them because they cancel each other out. And this one is, it doesn't mention that it's insoluble in water, or that and it only says that a precipitate form, so that one must still be aqueous. Okay, so now let's look and make sure that we've got this balanced, that there's nothing that we need to worry about with it. So we have on the left 2 sodium, on the right we have only 1 sodium, so we're going to need to add a 2 there to balance that. On the left we have 2 carbon, and on the right we have 3 carbon. So we're going to need to add something here that's actually going to mess up our sodium, but we'll come back to that in a minute. On the left we have 1, 2, 3 oxygen plus 9 more, that's 12 oxygen, and on the left we have 9 plus 6 oxygen, and I got the 9 from 3 times 3, and I got the 6 from 2 times 3. So we have 9 plus 6 oxygen over here, and we have 9 plus, is that right? Yeah, 3 and 3, 3, 9 plus 9, so we have 18. So this side needs a few extra. If we change that 2 that we have right here, go away, I know how to use you. So if we change this number to a 3, then we'll have a 9 over here. That'll fix it. That also fixes, no, it does not fix our sodium. So we'll end up coming back to that again. So do you see how I'm just kind of going back and forth so I can kind of fix it? You can do it in different ways, but I just hit one thing at a time and I keep going back and forth till it all is fixed. All right, let's see. There's an aluminum with a 2 here. And so let's put another 2 here. The oxygen is really the last thing we should touch because it is like everywhere. And so I probably won't look at that again until we're done with everything else. But it's nice to keep our count. Because I'm sort of losing count of what I have, I'm going to list all of our individual elements that we have. Make sure I didn't miss any. All right, sodium, carbon, oxygen, aluminum, nitrogen, more oxygen. Okay, I got them all. So right now, let's pause and let's just take a count. On the left, we have 6. On the right, we have 3. Well, let's fix that one. Now we have 6. On the left, we have 3 carbon, and on the right, we have 3 carbon. We're going to skip the oxygen because that one's just too messy. On the left, we have 2 aluminum. On the right, we have 2 aluminum. And then nitrogen, we have this 3 on the outside is for our nitrogen, so we have 3 on the left. And on the right, we have 6. Oh, just kidding. We don't have 3. We have 2. This applies to the aluminum and this whole thing. And because we have 3 here that applies to this nitrogen, we multiply that by 2, we have 6. So we actually have the right number of nitrogen. And now we're at oxygen. Why did I write a 2 after I counted 6? All right, and now we have oxygen. So we have 3 times 3 is 9 oxygen. 3 times 3 is 9, but then we got to double that. That's 18 oxygen. So we have 27 oxygen on the left. And on the right, we have 3 times 3 is 9 here. And then we have 3 here, but with the 6 out front, that means we have 18. And when we add those, obviously, we're still going to get 27. So the oxygen is now balanced. So that one was a little bit of a mess. But now that it's balanced, we've answered the question. So we have 3 of the sodium carbonate plus 2 aluminum nitrate yields aluminum carbonate. That's our precipitate. And 6 sodium nitrate. And we're done. As you're working through these, I recommend starting with things that are only in one location on each. I kind of didn't do that at first because I was just going left to right. When I hit that oxygen, I kept going with it. If you see oxygen is in 2 places, like it is here on one side, and 2 places like it is on another side, I recommend just skipping that and coming back to it at the end. So things like sodium, where it's only in one place on both sides, is a good one. Same with the aluminum, that one's only in one place on both sides. The carbonate has at least the carbon is only in one place on both sides, and then same for the nitrogen. So if you just leave the oxygen for last, it usually will kind of work itself out. And if it doesn't, then you can deal with it and do either your tricky fraction stuff like we did in a previous example, or you can do the other way that we did it, where we kind of double things so that we don't have to deal with a fraction. All right, that's a little bit hard to read, but you can read the answer in the book if you want to see it nice and printed pretty.